Okay, you guys. In this last video, I'm going to be covering your final exam review guide, problems 51 and 52. Okay, this is part 4 of the series that I'm doing today. Um, so we have a circle that we need to be concerned with, an ellipse that we need to be concerned with. Um, so let's actually move over to our whiteboard here. And let me pause really quickly so I can get a few things set up. All right, you guys, so I have the things I want to set up here. Essentially, just for time purposes, if you want to know more about conics, definitely review this section in Alex. If you have any questions, you can always ask me to review things with you or go through things a little bit quicker. But I'm just going to give you the gist of these. Essentially, for chapter 9, we talk about conic sections. Basically, if you took a cone or two cones and started cutting them in certain slice ways, you're going to get certain shapes, these shapes here. So a circle, a parabola, an ellipse, and a hyperbola. You've already seen most of these, I'm sure. Let's see if I can just roughly do these. So for a circle, okay, you have a center and a radius. I'm going to get into further detail with this, so don't worry about it yet. Parabola, you can have upward, downward, pointed to the left or pointed to the right. For an ellipse, you can have like an egg shape that looks lengthy in the y direction or in the x direction. And a hyperbola is kind of one of the weirdest ones. It's like two parabolas that are put together. So you're going to have these asymptotes. And you're either going to have a curve that looks like this on the top and the bottom, or you're going to have your asymptotes and a curve like this from side to side. Okay, now for your exam, you'll be responsible for the circle problem, particularly the type from problem 51. You'll be responsible for parabolas because we've been dealing with those for quite some time. And you'll be responsible for the ellipse stuff that we also cover today. Okay, now for all conic sections, they can be written in this particular form. So you have A, B, C, D, and E as coefficients, and then you have these powers of X and Y. Um, I'm going to get into the details of a circle and an ellipse in this particular video. So let me go ahead and erase these details. Okay, so for a circle, you're going to have an equation of form x minus h squared plus y minus k quantity squared equals r squared. Okay. Some things of note. HK is where your center is located. And R is your radius. Be careful because it's R squared on this side here. Let's color code a little bit. Okay, and then let's Make the radius a different color. It's a little bit too much the same. Okay, so note here, you have r squared. All right, so let's draw a little circle here. I'll try to make that as rounded as possible. Okay, so right in the middle will be your center. And then from that center to any point on the outside of the circle, you're going to have your radius r. Okay. All right, so let's go ahead and get into the circle problem, which is number 51, and then we'll come back to the ellipse stuff. So number 51, you have to find an equation of the circle that has center -3, 1, and passes through the point 6, -5. Okay. So this one's a little bit weird because you have to start with the formula for a circle first and then work your way back. Let me go ahead and just erase this top part. It's so messy. Okay. All right, so the first thing is to note that we have our center HK given. So center is HK, and that's equal to -3, 1. So that tells you H is -3 and K is +1. Okay, so here's our general formula. We have X minus H, the quantity squared, plus Y minus K, the quantity squared, and that's going to equal your radius squared. Okay, so start with general formula. Once you find your HK, plug those guys in. We have X minus -3, the quantity squared, and then we're adding Y minus 1, the quantity squared, and then that's equal to your R squared. So we have X plus 3 squared plus Y minus 1 squared equals R squared. Okay, so we've covered the part where the center comes into play. Now we don't have our R value yet, right? So let's actually keep that color coded. Come on, man. Okay. So what we're going to do, we're going to use this portion to find the radius. Okay, let's clear out this portion. Okay, so now we have the point 6, -5. That means x is equal to 6 there, and y is -5. So we're going to plug the x value of 6 in and the y value of -5 in, and then back solve for r. Okay, so simplify. You have 9 squared plus -6, the quantity squared. Very important to put parentheses there. That's 81 plus 36 equals r squared. So 117 equals r squared. Okay, so technically, your radius would be the positive square root of 117 since it's a distance. But remember, we were asked for the general formula. So let's go ahead and put our solution up top. The general equation for our particular circle is going to be x plus 3, the quantity squared, plus y minus 1, the quantity squared, equals 117. Let me save that and then clear this out. Next, we're going to look at an ellipse. We're going to look at it in standard form. Okay, so for for part 3, we were looking at ellipses. And there's two types. There's the horizontal type, which means it's longer in the horizontal direction. There's the vertical type. Your general equation for this is going to be x minus h, the quantity squared, divided by a squared, plus y minus k, the quantity squared, divided by b squared, equals 1. Okay. And for your ellipses, it's actually going to be the same formula for both. So we can go ahead and move this guy up here and box it. Okay. Essentially, for a horizontal, that means that the A term is going to be larger than your B term here. Come on. So A would be greater than B. So essentially, the part underneath the x squared term is going to be larger, which is going to stretch your ellipse in the horizontal direction. If it's vertical, that means A is less than B. So you're looking for the larger number underneath the y squared term. Okay, So also let's introduce a little vocab: semi-major, axis, semi-minor, axis. So let's kind of think about a horizontal ellipse. Let's see if I can draw one of these. Okay. So essentially your center is still going to be at HK. Okay. So there's your center. Now, if you have a horizontal ellipse, that means that A is going to be your semi-major axis. And that's going to be this length. Okay, so the entire length of the ellipse is actually 2A. Okay. And then the semi-minor axis would be B. So this length from the center up would be B, and from the center down would be length B. Okay. All right, if we're looking at a vertical ellipse, so hard to keep track of all the colors and stuff. Here we go. Okay, so again, we're going to have our center at HK. Okay, but now your semi-major axis is going to be B because it's longer. Okay, so this is still length B. And this is also length B. That's so ugly. Okay. All right, and then on the side, length A, length A. So let's write this in again, just for good measure. The semi-major would be B, and semi-minor would be A. Okay. Let's save that. I'm definitely tempted to go over hyperbolas in another video. There's some interesting similarities and differences between the ellipse equations that are useful to know. All right, so let's actually go back to our notes for this part so that we can just use this graph here. Okay, so your steps for this problem, your first thing is to find your center. C, which is at HK. So in this case, hopefully you're seeing that H is 5 and K is going to be -3. Because you could write this x minus 5 squared divided by 9 plus y minus -3 squared over 4 equals 1. Okay, so we found our center at 5, -3. So start at 0, 0, move over in the x direction to the right by 5, and then down by 3. Now here's the beautiful part about graphing your ellipse and circles, actually, if you had to graph them. You really just need to look out for what A and B are, your semi-major and minor axes. So to find A and B. Okay, so essentially Remember, a, for the way that I do it, it's always the part that's underneath the x squared terms. So I have x minus 5, the quantity squared, divided by, that's going to be 3 squared on the bottom. Okay, so what that tells me is that a is 3. Okay. Now I'm going to add, I have my y plus 3 squared divided by, what am I squaring to get 4? 2. Okay, so that tells me that b is equal to 2. Do I care which one's semi-major or semi-minor at this point? No. Once you start graphing, you will figure out which one is major and minor, but kind of think major is the larger one, right? Okay, so the 3 is underneath the x squared stuff. So you're going to move from the center out by a in the x directions only. Okay, so I'm going to move from the center out by 1, 2, 3. Okay, and then I'm going to move back 1, 2, 3. Okay, then for b, I'm going to go to the center and I'm going to move up and down in the y direction. 1, 2, 1, 2. Let's see if I can get this ellipse to look right. No. Let's see if I start there. I don't know where I'd have to start. Well, you guys will see me fumble with this for a while, I think. Let me pause and see if I can make it look a little better first. All right, took a little finessing, but I think I have to start pretty much up here and kind of fit it in the best I can. So let's do like that, and then let's move this. Okay. So that is how your ellipse looks. Again, just emphasizing that this length, ooh, nope, that this length here is A, and this length is A. This length is B, and this length is B. Okay. All right, that wraps up what you need from the end material for your final exam review. For pretty much all the other problems, we've gone over them in some kind of way, shape, or fashion, either via video or lectures, or we've had exams and things on them. Definitely let me know how you guys are feeling about this over the next few days, and I will check in with you soon.